everyone. In this video lecture, we are going to discuss about the continuity equation. Continuity equation is a very useful fundamental concept. This equation is used in many areas like fluid mechanics, thermodynamics, electromagnetics, and semiconductor area as well. Although this equation might be look different in different areas, but the basic principle on which this equation is based remains the same. That is the conservation of some quantity. When we talk about the continuity equation in electromagnetic domain, this equation is based on the principle of conservation of energy. That means energy can neither be created nor destroyed. But when we talk about the continuity equation in semiconductor area, this equation is based on the principle of conservation of charge. That means charge can neither be created nor destroyed. All semiconductor devices operate under non-equilibrium conditions in which electron and hole current flows through the semiconductor. So there we consider four mechanisms, and these four mechanisms are drift, diffusion, generation of the charge carriers, and recombination of the charge carriers. When drift, diffusion, generation, and recombination occur simultaneously in a semiconductor, the carrier transport is governed by the continuity equation. So in this video lecture, we derive the continuity equation. So in order to derive the continuity equation, let's take a semiconductor material in which we are measuring distance in the x direction. And the area of this semiconductor material is A. Now let's take an infinitesimal slice of the semiconductor. And denote this point by x and this point by x plus delta x. So this will look like a box, and the width of this box is del x. As the area of this slice is also equal to the A, so the volume of this box is A delta x. Now the number of electrons in this box can increase. Let's say the number of electrons in this box are increasing, and to increase the number of electrons in this box, there are two processes, and these two processes are: first process is if the rate of electron flow at x is greater than the rate of electron flow out of the slice at x plus delta x. If rate of electron flow at x is greater than the rate of electron flow at x plus delta x. Now let us assume J and x is the current density while entering the box, and Jn x plus delta x is the current density while leaving the box. So current densities are denoted by J suffix n because we are talking about the electrons. If we are talking about the holes, then we need to take an P here instead of N. But right now we are talking about the electrons, so we have taken N here. So J and X is the current density at X point, and J and X plus delta X is the current density at X plus delta X point. So the number of electrons in this box can increase if J and X is higher than the Jn x plus delta x. And second method is if the generation of charge carriers in this particular box, generation of charge carriers in this particular box higher than the recombination of the charge carriers. Higher than the recombination of the charge carriers. So these are the two methods by which number of electron in this box can increase. The first method is if the rate of electron flow into the slice is higher than the rate of electron flow out of the slice. And second is the if the generation rate is higher than the recombination rate. Now, in order to understand it in a more clear way, let's take an lake analogy. This is a lake. The water content in this lake can increase if the inflow of the water to the lake is higher than the outflow of the water from the lake. So this inflow is equivalent to Jnx and this outflow is equivalent to Jnx plus delta x. So this inflow and outflow will represent our first process. Now the second process is the generation and the recombination of the charge carriers. Now suppose we have sun. Sun will evaporate the water content, due to which water content in this lake will decrease. But at the same time, if we have clouds, then cloud will produce rain, and this rain will restore the water content of this lake. So sun is equivalent to the recombination, and through recombination our charge carriers are reducing, and the cloud is equivalent to the generation of the charge carriers. So as long as the generation of the charge carriers is higher than the recombination, the charge content in this particular box will be higher. Now let's say the number of electrons in this box are increasing. Now we represent it in mathematical terms. So this will be equal to del n by del t into A delta x. The unit of this particular quantity is number of electron per centimeter cube per unit time. But we are interested in the number of electrons in the particular box. So we need to multiply this quantity with A delta x so that we can get number of electrons increasing with respect to time in box. And this will be equivalent to Jn into A divided by minus Q, as this quantity represent the amount of current flow per unit area, or we can say the amount of charge flow per unit time per unit area, but we want number of carriers per unit time. So we need to multiply it with the quantity A and divide it by charge. So this quantity will represent number of electrons flowing into the box, and this quantity will represent number of electrons increasing with respect to time in box. Now this quantity will represent the charge carriers while entering at x. Now we have to calculate while leaving the box also. So for this we need to take Jn x plus del x into A upon minus Q. Now this quantity will represent number of electrons flowing out of the box. So these two terms we have considered: current density while entering the box, and this quantity is representing number of electrons flowing into the box. At the same time, we have considered current density while leaving the box, and this will represent number of electrons flowing out of the box. Now we have to take into consideration two terms also. First is the generation term and second is the recombination term. For generation, we represent it by using term Gn, and as the unit of the generation is number of electrons per centimeter cube, and we are interested in number of electrons per unit time, so again we need to multiply it with A delta x. So the unit of this factor will be number of electrons per unit time. So this quantity will represent number of charge carriers generated. Okay. So this quantity will represent number of electrons generated in the box. Now, next term which we need to take into account is the recombination. So for this also we need to multiply this with A del x. Here R is representing the recombination rate. This quantity will represent number of electrons recombined in the box only. So these are the four terms which we need to take into account while driving the continuity equation. First is the current density while entering the box. Second term is the current density while leaving the box. Third is the number of electrons generated in the box. And fourth quantity is the electron recombination in the box. So we can say the number of electrons in the box will increase with respect to time if the inflow of the electron is greater than the outflow of the electron, and if the generation of the charge carriers is higher than the recombination of the charge carriers. Now simplify this equation. So after simplify this, we will get in second step 1 by q jn x plus delta x minus jn x divided by del x plus gn minus rn. So this is the first equation. Now, by introducing the time function also, this equation will look like now by using the appropriate limits on both the sides, by putting del x tends to 0, we'll get limit del x tends to 0, del n by del t is equal to 1 by q del jn by del x plus gn minus rn. As this equation is a standard partial differential equation and the solution of this is del jn by del x when we put the limits, or we can solve it in other way also by using the Taylor series. So this is the first method by we can solve this equation, or there is a second method also which is the Taylor series method. So we can use here j and x plus del x. As you know, the expansion of fx plus h is fx plus del x into f dash x. Sorry, here h will come as we are expanding the series fx plus h. So now j and x plus del x will approximately equal to j n x plus del x delta z jn over del x. So we can put j n x plus del x delta z jn by del x in place of jn x plus delta x, and after solving this we will get the same expression. So this we have write in case of electrons. Similarly we can write for holes also. So in case of holes, the equation will look like this. Minus 1 by q del jp by del x plus gp minus rp. So these two equations are the single variable continuity equation. First equation is in the case of electrons and second equation is in the case of holes. So in this equation, we can say the rate of electron flow into the slice, if the rate of electron flow into the slice is higher than the outflow of electron from the slice, the number of electron in that particular box can increase. And if the recombination rate is lesser than the generation rate, then also electron present in the box can increase. So this is all about the continuity equation. Thank you.